This isn't a fishing boat. It's not a leisure craft, and it's certainly not some harbor toy. But right now, it's pressing its nose against the flank of a skyscraper-sized monster. Look at the scale. An ultra-large container vessel, a steel mountain carrying 24,000 metal boxes, towering over this tiny speck of a boat. It looks like a mosquito trying to move a mountain. But here is the paradox. That massive ship cost over $200 million to build. Its engine is a multi-story beast that generates over 100,000 horsepower, enough to power an entire city. Yet, as it approaches the harbor, that massive power is rendered useless. The giant shuts down. It essentially surrenders its life, its direction, and its safety to this grimy little vessel that's 100 times smaller. Why? Why would the most advanced logistics machine on the planet need to be babysat by a boat that looks like it belongs in a bathtub? The answer is as terrifying as it is brilliant. Without this tiny ant, the global economy doesn't just slow down, it stops. One wrong move by the giant, and $1 billion in cargo ends up at the bottom of the channel or wedged in the mud, blocking international trade for weeks. We call them tugboats, but they are the invisible shepherds of the sea. They possess a secret, concentrated strength that defies common sense. So, where is this power hidden? How does a boat shorter than a basketball court manhandle a vessel longer than the Eiffel Tower? To understand that, we have to look past the rubber tires and the rust. We have to go deep inside. Let's see what's actually powering the world's smallest heavyweight champion. Step into the wheelhouse, and the first thing you notice is the glass. Unlike the bridge of a mega ship, which feels like the cockpit of a passenger jet perched hundreds of feet in the air, the tugboat's command center is an aquarium. There are no blind spots here. A wraparound 360-degree view allows the captain to see every inch of the waterline, the towering hull of the client's ship, and the critical tension of the tow lines. Overhead windows let them look straight up at the massive steel cliffs they are nudging. In the world of ship handling, visibility is survival. The bridge is packed with ergonomic consoles, joystick controls that respond to the flick of a wrist, and radar screens that track the movement of every vessel in the harbor with surgical precision. It is the brain of the operation, designed for total situational awareness in a chaotic environment where inches mean the difference between a successful docking and a catastrophic collision. Descending the steep steel ladder, we arrive at the main deck, home to the ship's literal muscles, the winch. If the tug is the athlete, this is the tendon. This isn't your backyard truck winch. This is a massive hydraulic drum carrying thousands of feet of high-performance synthetic rope, some of which are stronger than steel cables of the same diameter, but light enough to float. These lines are engineered to withstand hundreds of tons of bollard pull, the maritime equivalent of a truck's towing capacity. When the winch engages, the groan of the hydraulics echoes through the hull as it tethers the tug to its giant companion. It is a choreography of tension and release managed by sensors that monitor the load in real time, ensuring the line never snaps even when the ocean swell tries to pull the two ships apart. Now, look at the hull. At first glance, it looks battered, ringed by what looks like oversized truck tires. But these aren't just old tires, they are specialized rubber fenders, often salvaged from heavy aircraft or custom, molded to absorb incredible forces. This is the tug's armor. While most ships are built to cut through the water like a knife, the tug is built like a sumo wrestler. It is wide, heavy, and carries a low center of gravity to keep it stable when it's leaning into a push. The steel plate of the hull is significantly thicker than that of a standard cargo ship, reinforced with internal frames to prevent it from buckling under the pressure. It isn't designed for speed, it's designed for impact. It is a vessel that spends its entire life intentionally crashing into other ships, but doing it with the grace of a professional dancer. But the real magic happens when you go deeper, below the waterline, into the heart of the beast. To enter the engine room of a modern tug is to enter a temple of pure, unadulterated power. In most vessels, the engine room is a small part of the overall structure. On a tugboat, the engines occupy nearly 80% of the internal space. Imagine two massive, medium-speed V16 diesel engines, each the size of a school bus, sitting side by side in a space barely larger than themselves. These engines are twin, turbocharged monsters, designed to deliver maximum torque at low RPMs. This is what engineers call power density. You are looking at 5,000, sometimes 10,000 horsepower, squeezed into a hole no longer than a few parked cars. It is essentially a massive, floating engine with just enough boat built around it to keep it from sinking. The heat in here is intense, the air thick with the smell of filtered diesel and hydraulic fluid. Every surface vibrates with a low-frequency hum that you feel in your teeth. This is where the power-to-weight ratio becomes a mathematical absurdity. A tugboat has more raw, pushing power per ton of displacement than almost anything else on the water. Thick, color-coded pipes weave through the space like the arteries of a titan, carrying coolant, fuel, and compressed air to keep the giants breathing. Massive gearboxes sit behind the engines, reducing the high-speed rotation of the crankshaft into the slow, unstoppable force needed to turn the propellers. It is a masterpiece of mechanical density, where every square inch is utilized to ensure that when the captain pushes the throttles forward, the water behind the boat explodes into a white water canyon. The deck is alive with precision during these operations. Down in the belly, the chief engineer monitors a wall of gauges, checking oil pressures and exhaust temperatures, ensuring the heartbeat of the ship stays steady under the immense load. Up top, the communication between the bridge and the engine room is a constant, disciplined rhythm. The moment the order drops via the intercom, the engines roar, and the floorboards shake as the turbos spool up. There is a palpable sense of urgency. When a 200,000-ton container ship is drifting toward a concrete pier, there is no room for a mechanical hiccup. The tug must respond instantly, shifting from a dead stop to full power in seconds. It is a high-stakes game of physics played out in real time, where the small crew operates as a single, seamless organism. From the outside, the tug looks like a humble worker caked in salt and soot. But as we've seen, its internal anatomy is a marvel of high-tech engineering. It is a vessel defined by its ability to endure, to push, and to pull until the job is done. It is the ultimate underdog of the engineering world, a platform that prioritizes function over form and substance over style. We have toured the bridge, felt the tension in the winches, touched the armor of the hull, and heard the roar of the massive diesels. We have seen the muscles and the nerves that allow this tiny ant to chen dika galot. But even with all this raw horsepower, even with the reinforced hull and the massive engines, there is still a glaring problem. If you simply push a mountain of steel with a small boat, the laws of physics say you should just bounce off, or worse, get crushed against the pier. Strength alone isn't enough to explain how a tugboat can spin a cargo ship around like a top. Having the muscle is only half the battle. So, how do you actually apply that force? How do you push a mountain without flipping over or being dragged underwater by the very ship you're trying to save? To find the answer, we have to look at the one piece of technology that changed naval architecture forever. It's a hidden weapon that lets the tugboat defy the very rules of the sea. The secret weapon that changed naval architecture forever is called the Azimuth Thruster, or more commonly, the Z drive. To understand why this is a game changer, you have to understand the fundamental weakness of a mega ship. Most vessels, regardless of their size or price tag, are designed like a dart. They have a fixed propeller at the back that pushes water in one direction straight. To turn, they rely on a rudder, a relatively small flap of steel that only works effectively when the ship is moving at a significant speed. But in a crowded harbor, moving fast is the last thing you want to do. The moment a 200,000-ton container ship slows down, it loses its ability to steer. It becomes a prisoner of its own momentum. It is essentially a skyscraper-sized freight train on ice, drifting blindly toward whatever is in its path with zero brakes and zero steering. This is where the tugboat flips the script on physics. Think about a high-performance drone. Why can it hover, spin in place, and dart sideways with surgical precision? It's because it can change the direction of its thrust instantly. A Z-drive tugboat operates on the exact same principle. Instead of a fixed propeller and a rudder, the entire propulsion unit, the propeller and its surrounding nozzle, sits in a pod that can rotate a full 360 degrees. It's called a Z-drive because the power from the engine travels down a vertical shaft and then through a set of gears that look like the letter Z to reach the propeller. This allows the tug to do things that seem to defy the laws of the sea. It doesn't just go forward and backward. A tugboat can thrust at 45 degrees, 90 degrees, or spin on its own axis while maintaining 100% of its engine power. It can literally walk sideways across the water, pushing against the hull of a giant ship while moving at the same speed. This is vectoring thrust at its most primal level. While the giant ship is trapped by its own inertia, the tug is a master of direction. It doesn't just push against a ship, it redirects the very forces of nature. But raw thrust is only ha-ha-ha moment. The real magic lies in the math of the pivot. You might assume that moving a massive vessel requires pushing against its entire weight with equal force. But a tugboat captain doesn't fight the ship's weight. They fight its center of gravity. They use leverage. By applying force at the extreme ends of the ship, the bow or the stern, the tug uses the massive length of the cargo ship as a lever. It's the same logic you use when opening a heavy door. If you try to push the door near the hinges, it's nearly impossible to move. But push at the handle, the point furthest from the pivot, and the door swings open with a single finger. The tugboat finds that handle on the giant ship. By nudging the bow just a few degrees, they create a massive rotational force that pivots the entire quarter-mile-long vessel around its hydrodynamic center. It is surgical, it is calculated, and it is the only reason these giants can navigate the tight bends of a river or the narrow gaps between concrete piers without causing a billion-dollar disaster. This brings us to the strategic truth of the harbor. In the open ocean, the container ship is the undisputed king. Its massive engines and streamlined hull are built for the brutal efficiency of crossing 5,000 miles of salt water at a steady clip. But the second that ship crosses the harbor line, the hierarchy of the sea is turned upside down. On the high seas, speed is life. In the harbor, speed is a liability. In these restricted waters, the only currency that matters is control. The tugboat is the brain, the brakes, and the steering wheel for a giant that has lost its own. It is a strategic partnership where the small dictates the terms to the large. The tugboat turns a potential catastrophe into a choreographed masterpiece of logistics. It takes a vessel that is functionally a blind, unstoppable missile and transforms it into a precision, guided instrument. When you see a tugboat pushing against the rust-streaked side of a mega ship, you aren't just seeing a small boat helping a big one. You are seeing a triumph of torque over momentum. You are seeing a masterclass in the application of leverage. It is a reminder that in the world of engineering, being the biggest doesn't mean you are the most powerful. The most powerful player is the one who can control the forces at play. This brings a whole new meaning to the phrase, small but mighty. Every time you order something online and it arrives at your door, there is a high probability that a tugboat played a role in that journey. It is the invisible backbone of global trade, a CMI that proves that precision beats power every single day of the week. But behind all this high-tech vectoring, the joystick controls, and the V16 engines, there is one final piece of the puzzle. All the technology in the world is useless without the heartbeat of the crew, because at the end of the day, wrangling these giants isn't just a job, it's an art form. The tugboat is a profound reminder that in a world obsessed with scale, size is often a distraction. We gaze at the massive container ships and the soaring cranes of the harbor, but we overlook the invisible shepherds working in the shadows of those steel cliffs. These vessels prove that the most critical components of any system are rarely the loudest or the largest. Strength isn't about displacement, it's about the grit to stand your ground and the precision to apply force exactly where it's needed most. It's about being the steady hand that guides a giant through a storm. That's a mission we take to heart. Much like the crew of a tugboat, we are a small, dedicated team of animators and researchers. We don't have a massive corporate engine behind us, but we have a passion for the details. Every frame of these original 4K 3D animations and every deep dive into maritime physics is our way of hurting the giants, taking complex engineering and moving it into a format that everyone can understand and appreciate. We believe that a small team can have a massive impact, but only with the right support. If you enjoyed this journey into the belly of the beast, please support our team by subscribing and dropping a like. Your engagement is the high-pressure fuel that keeps our engines turning and allows us to bring more of these mechanical marvels to life. Drop a comment below and let us know what piece of engineering you want us to solve next. Thank you for sticking with the little guy and for supporting exclusive engineering animations made just for you.